Good morning, students. Today we will discuss about simple problems on psychrometry. How we will extract the properties from the psychrometric chart. Well, because while we are moving to industry, we can't calculate what is the partial pressure of air, what is the partial pressure of water vapor. It is too difficult. What is the dew point temperature? What is the wet bulb temperature, dry bulb temperature, specific humidity, humidity ratio, relative humidity. These many properties we can't measure. So simply we are measuring dry bulb temperature, wet bulb temperature, and by using psychrometric chart, we are extracting the properties. So we will practice some problems. Then we will get clear idea how best we can utilize the psychrometric chart for designing the air conditioning system. First one, you see, consider air water vapor mixture at zero point 0.1 megapascal, 35 degrees centigrade dry bulb temperature and 70% relative humidity. Determine wet bulb temperature and specific humidity of air using psychrometric chart at 1 atmosphere. From above data, determine the dew point and the enthalpy of air by using the psychrometric chart. First, you see the given data. At mixture at air and water vapor mixture at zero point 0.1 megapascal. 0.1 megapascal means into 10 we will get the 1 bar means atmospheric pressure only. At atmospheric pressure, air and water vapor mixture is available. What is the dry bulb temperature is 35 and what is the relative humidity is 70. So once we know the two properties, at least two properties are required to determine the condition of the air. So 35 degrees is dry bulb temperature and relative humidity is 70. Once we know the condition of the air, based on that, by using psychrometric chart, we can calculate we can extract the properties of wet bulb temperature, specific humidity or humidity ratio, dew point temperature, and enthalpy. Okay, directly I shown the answers. How we extracted, I will explain. This is the psychrometric chart. You can see initially 35 degrees centigrade, 20, 25, 30, 35, 40. This is the 35 degree centigrade line. And 70 relative humidity. This is 100, 90, 80, 70. Okay. The 70 relative humidity line and 35 dry bulb temperature line where it is intersecting. This is the intersection point. So this is the condition of the air we marked on the psychrometric chart. How we marked? Just 70 relative humidity line and so these two lines on psychrometric chart, dry bulb temperature is 35 and relative humidity is 70. Here it is intersected. Once you mark the condition, what are the questions they asked? First one, wet bulb temperature. These are the inclined lines. So this is the wet bulb temperature line 30, but it is above 30 the intersection is there, maybe around 30.8 or you can mark 31, not 31, less than 31 only, 30.8 something wet bulb temperature. Next one, specific humidity line is a 0.020, 21, 22, 23, 24, 25, 26, 0.026 kg of water vapor by kg of air. This is the specific humidity. Next one, enthalpy. Enthalpy, same wet bulb temperature line you can extend up to enthalpy where it is intersecting. This is around after 100, 100.5 something. After 100, maybe after 100, the intersection is taking place. Maybe 112, 0.5 kilojoules per kg. Next one more question they ask. Dew point temperature. It is important. Dew point temperature, for determination of dew point temperature, what we are doing? We are moving horizontally upon the saturation line. Moving horizontally upon the saturation line where it is intersecting. At that particular point, what is the dry bulb temperature? The dry bulb temperature you can see 20, 25, 30, less than 30, maybe 28 something. Same we extracted. I will show. This is a dew point temperature is the 28 degrees, wet bulb 30.5, specific humidity is 0.026, enthalpy is 102 kilojoules per kg. Same from the graph. You don't want to calculate. Just you know two properties, mark the condition of the air. From that point, determine the remaining. Only for determination of dew point temperature, we are moving horizontally upon the saturation line. At that particular point, what is the dry bulb temperature? That is only the dew point temperature. Okay, we will solve one more problem. Then we will get the clear idea. Same method. Atmospheric air is at 35 degrees centigrade dry bulb temperature and 80 relative humidity. 35 and 80 relative humidity. Here they asked only two things, specific humidity and dew point temperature. You see, 35 degrees centigrade. This is the 35 degrees centigrade line and 80 relative humidity. 100, 90, 80. This is the 80 relative humidity. Where it is intersected here. Maximum specific humidity is 0.030. It is 0.029 kg of vapor by kg of air. Next, dew point temperature, how we are determining? Just we are extending the line upon the saturation curve. Then at that particular point, whatever the dry bulb temperature, that is only the dew point temperature. Is around above 30 degrees. You can see how much we got. Dew point temperature is 31.5. Specific humidity 0.029 kg per kg of air. Means only one thing we want to recall. Just you mark the condition of the air, that's all, from the given data. They will give two properties. At least two properties are required to mark the condition of the air on psychrometric chart. Once you mark the condition, then at a particular point you can extract anything. Wet bulb temperature you can extract, enthalpy you can extract, whatever it may be. One more problem will solve. Generally in industry, what we are measuring? We are measuring dry bulb temperature and wet bulb temperature. Atmospheric air at 1 bar is common and is at 25 degrees centigrade dry bulb temperature and 15 degrees centigrade wet bulb temperature. One dry bulb is 25, wet bulb is 15. Generally in the industry we are measuring these two temperatures only. Calculate relative humidity and specific humidity of the mixture by using psychrometric chart. So this is the common practice in industry. You can see first mark. One is dry bulb temperature 25 degrees. You see dry bulb temperature 25 degrees. Wet bulb temperature it is a 15 degrees. It is a 15 degrees. 20, 15, 10. This is so is 15 degrees is the wet bulb temperature and 25 degrees is the dry bulb temperature. Where the intersection happen, this is the intersection point. So now you see what is the relative humidity. This is the relative humidity is 30. The question asked what is the relative humidity. Because for measurement of relative humidity we are using instrumentation, but it is not giving exact values. Sensor error is too high. Instrument cost also high. And we are getting the deviation of error it is too high. Instead of that, better measure the dry bulb and wet bulb temperature for measurement of the relative humidity. It is we will get the exact values. 30% is the relative humidity. That is only the question they asked. 30% relative. Next question. Atmospheric air at 1 bar and is at 35 degrees dry bulb temperature and 25 degrees wet bulb temperature. Determine the enthalpy dew point temperature of the mixture. I determined the relative humidity also because our major measurement relative humidity also required. You see, next one. This is the dry bulb temperature is 35 degrees. I changed the colors for easy identification. The next problem. The dry bulb temperature is 35 degrees. Wet bulb temperature is 25 degrees. 20, 25, 30. Wet bulb temperature is 25 degrees. Where the intersection happen? The relative humidity you see around more than 40 percentage. More than 40 percentage is the relative humidity. Next, what they asked? What is the dew point temperature? Enthalpy, just you extend this one 70, 75 or 76 kilojoules per kg. Next, what is the dew point temperature? You extend horizontally on the saturation line. At particular point, what is the dry bulb temperature? The dry bulb temperature is above 20 degrees. You see, 21 degrees dry bulb dew point temperature is 21 degrees. Enthalpy 76. Relative humidity is 45%. So, I think you got a clear idea about how we can extract the properties from the psychrometric chart. Majority of the models I explained, remaining you can practice yourself. Thank you. Thank you very much.